Do you agree this? Do you agree this?
Yes.
To be recorded. Okay.
Yeah.
I agree too. Okay. All right. Let's get on with it now. All right. Okay. So let's get started with the language feature that we are going to add. So, okay. So let's go into CW script. All right. So this is the code that gets generated, and I added some now when I generate the code, also you can see how it's walking through the code. For example, begin let statement, begin integer value and integer value and let statement, right? Assign struct val, right? So then you see this is the ident. You can see like what is being generated, and then that. So that's cool. I can kind of show you now how we might get like a source map. So if we go into the AST to Rust, so it's not AST to CAM anymore, it's AST to Rust.
Okay.
I might do, okay, so
You on
look, this member,
you're on main, right?
yeah, m.ctx.text. Here, let's do translate ident, and then like, cool. Yeah, so let me just show you what this would look like now. Here, ctx dot x dot ctx dot text. Let's do right. You'll see it's very interesting. Oh shit. This is probably not good to put, because it actually puts out the whole text of it, so probably it's not good to put that all out.
Yeah.
Okay. Code group. Oh, I have regular expression on. Okay, state item set. So maybe sorry. Yeah, state item, so we keep it like that. Okay. Assign statement, maybe I can have the whole AST node. So a statement dot context dot text. So I can, all right. I think I've here, let statement as well. Do statement dot ctx dot text. Integer val, I can do val dot ctx dot text. Basically it gets the code and then puts it in. I think here I can do that too. X dot ctx dot text. All right. All right. Member access. Yep. Okay. I think I have almost everything.
Yep.
Okay. So run that again. Hopefully don't get any error. Okay. Let's see. All right. So now we can see that, right? We have some, at least it's helpful for debugging. Now we know where is the begin and end of certain things,
Yeah.
right? For example, this one, you can see that there's no spaces. Right? The spaces are not taken because it just takes all the tokens. The spaces, as we define, has been skipped.
see. Yeah.
But it's interesting to now see like where that maps into code. And then there's actually a source map thing. All right, so let's go back to the language feature that you'll be implementing this week. So we can go to the, I don't think it'll be too long. I think you can probably get it within a day or even less. But just to give you familiar with the whole system, I think it'd be helpful to have you implement one of these language features. So if I go to the example.cws, CW20 base. All right, I am in the process of making the VS Code extension again, but that means I had to take that out.
Yeah.
So of the marketplace, I have no syntax highlighting. Okay, let's talk about the language feature. So now you kind of know that, how do you define the state, how you define that, and you can see how you also do this.
Follow.
Yep. I was thinking to add a list comprehension style thing, like you can see in
Python.
Python, yeah. So like state dot balances equal
Oh, I see.
equals
Yeah.
2, right? And then we can do state dot balances 0, or let's say x for +1 for x in state dot balances, which is probably not code you should write because of how inefficient it'd be. It did many state loads.
Wait, does Solidity has like that comprehension, a similar feature?
Ruby?
No, Solidity.
No.
Okay, because I feel like we want to make this kind of script for like Solidity that we want to
No,
mix.
no, no. We're not targeting Solidity devs
Yeah.
in particular.
Yeah.
The similarities come from the fact that Solidity is close to CW script in the level of abstraction.
Yeah.
Like we're thinking in the contract level, not at the level of bytes and serialization and storage. We don't need to think about that. That's why it seems so familiar to Solidity, because you're thinking in the same level of abstraction. It's not supposed to be, for Solidity devs. It just happens to be at the same level that you're thinking of. The concepts are the same, like level of abstraction. So the idea is that CW script, one of the people that I talked to earlier this morning, they asked me if CW script could be compiled to Solidity, and the answer is yes, right? Because they work at a similar level of abstraction. CW script doesn't need to be, even despite its name, CW script doesn't have to be just for CosmWasm. It can be equally valuable for Solidity, because it can work as a true multi-chain developer experience. Okay, BRB. You get my other lunch, my second lunch.
Okay.
Okay. All right. I promise it's the last lunch.
All right, cool.
Yeah, I'm not losing any weight. All right. So where were we?
Yeah, so we want to add the list comprehension.
Yeah, list comprehension. Do you have any idea how you might do it?
Yeah,
So we
I
probably
think,
go to the go ahead.
no, I was just thinking. So the bracket, right? So it's gonna be we actually need to distinguish that with the like the normal array.
Yeah. Yeah. So there's a precedence, right?
Yeah.
So if you go into the grammar, script parser, right? The current bracket one is called a vec val, right? A vec val is a val, which is an expression because it has a value, right?
Yep.
And then maybe you have to write something before it to maybe check like lbrac. Like it could be a comprehension, right? And then lbrac, and then rbrac,
Yep.
and then let's call this like list or list comprehension, right?
So we need the comprehension.
Right, and then comprehension might be like a expr, and then for, right, or for, and then ident in like ident or expr, right? Something like that.
Yeah. Yeah. Well,
Right.
I could be a while loop, but I'm not sure if Python support while loop for
I don't know. No, I think it's just for.
for.
Well, I think they have a while. I think they have a if as well, or like they have a if.
Yeah. Let me take a look.
And then they have an else in, but we don't want to make it exactly like Python. Well, okay, so basically, I think they have an if.
Yeah.
Yeah. You also notice that our programming language doesn't have while loops.
All right. Yeah.
Because, I don't know. The thing is, like, I don't think a while is needed for a smart contract, and our language design goal is to make it easy to do the right thing and hard to do the wrong thing. All right. So this comprehension, also, I want to get your opinion on it. If you think that it's actually really necessary, or is it helpful? Because anything with iteration is usually very expensive. Yeah. So you let me know.
No, I feel like I don't know, like in terms of the performance, like the normal while loop and then this comprehension, I'm not sure like which one is actually faster.
No, it's probably the same because they're going to expand to the same thing. It's just easier to type. Except the thing is, should we make it this easy to make it iterable? Anyway, because like usually, what are you going to do with that? You're going to build like a big data structure, right?
Yeah.
And I'm not sure if you want to build this big data structure.
I think it's useful. No, I think it's useful, but probably not the highest priority for the language.
Okay, yeah. It's probably not very high priority. Probably we need to be thinking about like easier ways to do sub messages, easier way to do call other contracts, make it linear instead of like actor model. Right? How do we make it? How do we add like testing features? Right? How do we write tests?
Yeah, I think
stuff like that. Right?
Assert. Do you have assert already?
Yeah, I think no, I don't have assert yet. We should add it.
Yeah, I think that's probably the
Okay,
actually
so
require. Do you have require?
I don't think. Okay, so require. Okay, so how would we go through this? So what would I type? Okay, let's say that I can. Let's do this. Let's assume that only the minter can write it. So what would I do?
Just require. Start require, and then
Require.
open parentheses.
Open parentheses.
Yeah.
Are you sure
And
you want to use require over assert?
I mean, normally people use require all the time in the contract. So
Yeah, but then if I'm in a yeah, true. You're right. It's more true to it's more true to English to say require.
assert is probably more like testing. Yeah, I think requires probably make more sense. Yeah, maybe we can do like require and then the address equal owner, and then you can. It
Okay,
could take
so
multiple
require,
parameters.
right? Recipient equals
The owner.
so state that owner.
Yeah, and then you can add an error message at the end, like comma.
Why?
No, you
Okay,
can
so
add like you can add error message, like two. Basically, that's two arguments.
okay,
Yes.
okay, yeah, and then the
Must be
error.
owner. Yeah, something like that.
Yeah. So the thing is, I don't like too many. Maybe we just make this a statement.
Okay.
Like we can just make a statement. So I'll let you play around with this, and then let's put that in something where we're going to add today is basically how to trigger errors the right way. Because right now I only have if recipient doesn't equal What do you think of like else?
Yeah.
No, because thing is like I have the error. Because right now I have this
Yeah.
owner fail error blah blah blah.
Why don't we just actually no yeah, you probably can do the same thing, right? Just use the
Yeah, I'm not sure if we need like another keyword. So what I had also a thing was like maybe we have like a check, basically like a modifier in Solidity. So we have a check like recipient is owner, right? And then fails with and then error. Let's say that. And then what we do is I put like a tag here, and then like so it would look like something like I don't know, or like here. So those are like tags, or I could do like recipient is owner, and then it's like on adder. I don't know, but see, like this is where the language design comes in. So we should start a document for each of these. So let me start a document right now. Let's see, H2. H2. Language design. Wait, what the fuck? Oh. Ouch. Let's language design, delete. Man, I hate Notion. Okay. Language design. Page. So I'm assigning it to this. Assert. So this basically we have to go over candidates.
Yeah.
Assert, require, checks. Okay, so candidates, right? I'll have you like write the options, right? Candidates.
Okay. It's under. Where you put that page? And
it's in the CW script. All the way at the bottom. Language design.
Okay.
Yeah. Goals. Candidate designs.
Candidate design.
So what is the basically summary? Right. The goals create an easy way for contract message handlers to check conditions and abort if with error if conditions are not met.
Yeah.
Create easy / legible. Okay, so the priority is always. Let me just put this here. Call out statement priorities. Number 1. Legibility, clarity, correctness.
Yeah.
2, clarity. So number 1 is safety and correctness. Number 2 is clarity. 3 is legibility. 4 is performance. And 5 is extensible.
So the performance parts, I think it's hard to tell, right? Depends on what kind of keyword we're gonna convert into, right? For example, if you use check in CW script, like which rough key that we're gonna map to.
No, like it's probably gonna turn into if statements.
Okay.
So like the performance is mostly about the overhead that we add in the standard library. Like, would this fit in the library? Like, for example, one of my ideas is that every number becomes like a big number in TWScript.
Okay.
Right? Like it's very like easy to use.
Yeah.
But actually, I think that the performance hit is actually not too bad. The reason is well, just for like, unless you're storing a bunch of like different contracts. The reason is because WASM, the WASM, code instructions, doing that is actually very small. Like the cost in gas. The expensive things are things that interact with the Cosm WASM API, such as interacting with the chain, querying, calling messages, saving data. That is the expensive part. But but it's actually quite cheap to do, like, if I wrap every number in an object, that is very, very cheap. Yeah.
Okay. All right.
Okay. So we have checks on arguments. Okay.
Hey, give me 2 minutes. I need to pick up a quick phone call.
Okay. I'll start eating my.
Yo. Hey, you want to hop on a call at like, I don't know, 7 after you eat? I'm gonna grab dinner too, and then we
Okay.
talk after.
Yeah, sure.
Yeah.
Sure. Yeah.
Yeah,
Sounds
I'll ping
good.
you. All right.
All right. See you, man.
Yeah.